Today's lesson is on rational expressions. This is the sixth unit of the sixth section of our review unit. The essential question for this section is, what are rational expressions and how do you perform operations on them? So let's start out by defining what a rational expression is. A rational expression is the quotient of two polynomials. Two examples might look like x over x squared minus 1, or x squared plus 1 over x squared plus 2x minus 3. Now, because the set of real numbers for which an algebraic expression is defined is referred to as the domain of the expression, and the fact that rational expressions indicate division, and division by zero is undefined, we must exclude numbers from a rational expression's domain that make the denominator zero. And if we look at our examples here, the first example, x over x squared minus 1, it's obvious that for that particular expression, x cannot equal 1. Because if x equals 1, then we have 1 minus 1 in the denominator, or 0. And similarly, for the second expression, x cannot equal minus 3, or x cannot equal 1. So these are values which would make the domain be 0, and therefore undefined. Next, we want to consider simplifying rational expressions. And a rational expression is simplified when the numerator and the denominator have no common factors. So basically what you want to do is you want to factor the numerator and the denominator completely, then divide by any common factors. So let's say as an example we were asked to simplify x to the third plus x to the second over x plus 1. First thing we're going to do is we're going to factor both the numerator and the denominator. So when we factor the numerator, we realize that there's a common factor of x squared. So we factor out the x squared, which leaves us with x squared times x plus 1. And the denominator is already fully simplified, so we can't do anything with that. And we notice we've got x plus 1 over x plus 1, so therefore those can cancel out. And what we end up with is simply x squared. The next thing we want to talk about is multiplying rational expressions. Now what we need to remember when we multiply rational expressions is, again, to initially factor all the numerators and denominators completely, then to divide both numerators and denominators by common factors, and then to multiply the remaining factors in the numerator and multiply the remaining factors in the denominator. Let's look at an example. So let's say we've got x minus 7 over x minus 1 times x squared minus 1 over 3x minus 21. The first thing we're going to do is factor completely both numerators and denominators. So if we factor x squared minus 1, that becomes x plus 1 times x minus 1. And if we factor 3x minus 21, that becomes 3 times x minus 7. Now, if we look for common factors in the numerator and the denominator that we can cross off, notice we've got x minus 7 in the numerator and x minus 7 in the denominator. And we've also got x minus 1 in the denominator and x minus 1 in the numerator. So canceling these out, our result is x plus 1 over 3. So here we've multiplied two rational expressions, simplified them, canceled out common factors, and our result is x plus 1 over 3. Next, we're going to talk about dividing rational expressions. Now, remember what a rational expression is. Basically, it's a fraction. And whenever you divide fractions, you have to take and flip the second fraction, or get the reciprocal, and multiply. So once you flip the second fraction, or second rational expression in this case, you can just follow the rules that we had for multiplication. So let's look at an example. So let's say we have x squared minus 2x minus 8 over x squared minus 9 divided by x minus 4 over x plus 3. So if we factor the first expression, the x squared minus 2x minus 8 becomes x minus 4 times x plus 2, and the x squared minus 9 becomes x plus 3 times x minus 3, and we flip the second rational expression, so now it's x plus 3 over x minus 4, this is what we end up with. Well, now we should look to see whether or not we have anything that we can cancel out. And if we look at it, we notice we have x plus 3 in the denominator on the left side, and x plus 3 in the numerator on the right. So we can cancel those out. We also have x minus 4 in the numerator on the left, and x minus 4 in the denominator on the right. And the result is simply x plus 2 over x minus 3. Now let's talk about adding and subtracting rational expressions. Now, just like fractions, if the denominators are the same, adding and subtracting rational expressions becomes fairly trivial. So let's say we've got x over x plus 1 minus 3x plus 2 over x plus 1. Notice the denominators are the same, so that's going to stay the same, and all we're going to do is basically subtract the numerators. So now we have, when we combine the numerators, we have x minus 3x minus 2 and a single denominator of x plus 1. So we've simplified it down to a single expression. Now if we simplify the numerators, our final result will be minus 2x minus 2 over x plus 1. But wait a minute. Notice that we can simplify the numerator some more. So now, when we factor a minus 2 out of the numerator, we get minus 2 times x plus 1. The denominator is x plus 1. And we can further simplify this, since we get x plus 1 over x plus 1. They are simply going to cancel, and my final answer here is simply minus 2. So now let's look at another example when the denominators are not the same. Say we've got 3 over x plus 1 plus 5 over x minus 1. Notice the denominators are different, so we have to come up with a common denominator before we can proceed. So to get a common denominator, we're going to multiply the left expression by x minus 1 over x minus 1, and the right expression by x plus 1 over x plus 1. So this will give us a common denominator of x plus 1 times x minus 1. So now we have 3 times x minus 1 plus 5 times x plus 1 over x plus 1 times x minus 1. If we distribute the 3 and the 5 and combine like terms, we should end up with our final solution. So now we have 8x plus 2 over x plus 1 times x minus 1. Now notice we can still factor and simplify the numerator out slightly. So our final fully simplified answer is 2 times 4x plus 1 over x plus 1 times x minus 1. Now I would like you to subtract the following rational expressions and put your result in the drop box.